So I've started recording. So let me introduce this course first. Okay. So this course particularly emphasizes on the AWS Solution Architect Associate course, and it is not an easy certification. So if you're not working on the AWS, just reading through the slides and going through the videos will not make you pass the exam. So we need to deep dive into each service, understand the scenarios. Okay. So what type of question are going to be there in the exam? What type of scenarios? So in the examination, most of the time you are not going to find out the easy questions. There will be a scenario based question where multiple services will be involved. So for example, they will give you a question like in a BPC, there will be a subnet, and inside the subnet, there is a virtual machine which is talking to a particular database. Now, in this, there are 4 services involved. So, if you know the individual service and do not know how to integrate between the services, it will be a tough exam to crack. Right. Okay. So, but as I said, we are going to cover almost from the starting, from the basics. So, don't worry about it. We will see how services communicate to each other, what is the uh, the real life use cases examples of that. So we are going to cover all of this in our 50-hour long journey. And to start with the class, if you have some basic idea about the IT knowledge, then it is okay. Apart from it, uh, we are going to cover everything. Okay, but if you want to be a good cloud engineer, so basic knowledge of Linux is somewhat mandatory, because we are going to learn, for example, AWS CLI, or there is something called Cloud Shell. So in AWS, there are multiple ways of doing the things. We can do the things from the graphical user interface, but graphical user interface is only for the beginners. So let's say if I want to create one virtual machine, I'll just go to the console and I will create a virtual machine. But when you have to create 100 virtual machine or 500 virtual machine, you're not going to go and create machines one by one. You need certain automations for it, right? So for that, if you know the Linux, it will be an added advantage. But to like pass the examination, it is not necessary. But to implement AWS and become a very good cloud engineer, you will certainly need a basic of AWS will be very necessary. And if you are completing this course, we can primarily go not only for the solution architect examination, but you can go do the cloud practitioner as well as the developer as well as the sysops associate as well. But primarily this course will be focusing on the solution architect associate examinations. Okay, but if you want, you can cloud practitioner you can easily take, but for the developer and sysops, your preparation will be 85 to 90% done. 10% you need some additional course specific thing, but you can do that as well. And in this course, we are going to cover more than 30 services, and these services are the core services. So we are going to see there is a different type of services is there. In AWS, there's more than 250 plus services are available. Okay, and you do not need to understand each one of it. Even I do not know like many of the services are. So you can learn those services as and when needed. You should be focused on the fundamental services. So that is around 30 plus AWS services is there, and we are going to cover all of them. And absolutely no prerequisite is necessary. We are going to start from the very basic. So this is about the course introduction. Any question in the course introduction? Then we will start with the AWS. Okay. So now we need to understand what is AWS. So before understanding what is AWS, we need to understand what is cloud computing. So guys, do you have any idea what is cloud computing? Any definition, anything you are aware about what is cloud computing?
Basically, it's basically like you have your computer, but it's remote, and you are working through the cloud. That's all.
Okay, but Albert, in that case, if you're saying your computer at the remote, so let's say you have a physical data center and you have a virtual machine there. You take a RDP session to those machines also, right? So in that way, also you have a computer that is on remote.
Yeah, you have the systems and the software which are all remote. Then you
Hmm.
have access to the machine with the software.
Okay, so
You're giving certain accesses and permissions, right?
okay, so what you're saying is like the very basic definition. It's not entirely uh, accurate, but so basically, cloud computing, there are very buzzword in the definition of the cloud computing. So, cloud computing
Okay.
is on-demand delivery.
Ah, okay.
Okay, it's a very I would say very important characteristics of the cloud computing. It's a on-demand.
Yeah.
So whenever you need,
Yeah.
you create an resources, and if your work is done, then you can delete it. So it's on demand. If you need one instance, you are going to create one instance. If you need 100 instance, you can create 100 instance. So cloud computing
Great.
is the on-demand delivery of the IT resources.
Yeah. Got it. That's very good.
Okay, so IT resources means you can not only create the computers that you can access on demand. There are multiple things you can do. Like you can create databases, you can create computers, you can create storage. You can now, as we move further in AWS, you are going to see there are machine learning related services, there are AI related services. So it's not about only about the computer. You can create IT resources on demand. Okay, with, and this is the third most important characteristics of the cloud, with pay as you go pricing.
Yep.
So we call it somewhere consumption based model as well.
You're just burdened with operating expenses, right?
Yes, that is correct. So I'm going to come
No
on that.
capital expense.
Uh, so pay as you go is like you're charged for the electricity, right? So the amount you are
Yep.
going to charge, the amount you are going to consume, you are going to charge accordingly. So if you, let's say, keep all your appliances open for a month, your monthly electricity bill is going to be high in comparison to when you are keeping your appliances application low, right? Similarly, in the cloud computing, let's say if you created one virtual machine, then you will be charged for that one virtual machine. But if you create 100 virtual machine, you are going to charge for the 100 virtual machine. But let's say you created 100 virtual machine, but you are using those virtual machine only 1 hour per day. Okay. So then there will be 20 hour, 30 hour of your uses for your machine, and total you are using for 100 machines. So 300 3,000 hour you will be charged. But if you are using these machine for 10 hours, so then you will be charged for 30,000 hours. So there are different pricing model for different services. So like for storage, you will be charged on how much data you are storing, right? For compute, you are going to charge how much time you are running for it. So there are different. So for example, there will be load balancers. So load balancer will be charged how many requests they are handling. So there will be different pricing model for each type of services, and we will cover the pricing model as along with the service. So if we will be reading about the AWS EC2, then we will see how EC2 is charged. Then we will see S3, so then we will see how S3 is charged. So cloud computing is the on-demand delivery of the IT resources over the internet as with pay as you go pricing. So instead of buying, owning, and maintaining the physical data center and servers, we can access the IT resources or the technology service such as computing power, storage, database on an as need basis from a cloud provider like AWS, Microsoft Azure, or GCP. These are the three prominent players. Apart from it, there are smaller player also available like um, Alibaba Cloud, Oracle Cloud, Huawei Cloud, DigitalOcean. There's multiple cloud providers are available. So our focus in this course is going to be AWS, and this definition is true for all the cloud providers. Now there is different type of model available in cloud. So first is public cloud, then we have private cloud, and in the last we have hybrid cloud. Okay. So in this course, when we are talking about the cloud computing, we are talking about the public cloud computing. AWS, Azure, GCP, they all are example of the public cloud. So whenever we say we are learning the cloud computing, it basically means we are learning the public cloud computing. So public cloud.
Hey, sorry to disturb. I have a question here. So you said we will be provided with the slides, right?
Yeah.
And
yes.
So my concern is, do we need to write some note
No,
based
I
upon
will
what you are writing here?
No. So everything is there in the slides. And apart from it, after the class, I will export this whiteboard as a PDF and I will upload this to the OneDrive as well. So you will be able to refer this notes as well.
Oh, okay.
Right?
Thanks for clarity. Okay.
Yeah, no problem. So I was discussing about the public cloud. So whenever we are saying we are learning the cloud computing, we basically means the public cloud. So public cloud is
Can I ask a quick question?
Sure.
So can I think of the public cloud as the internet and a private cloud as an intranet?
Definitely, yes. Most definitely, yes. Correct. So for example, AWS, GCP or Azure, they are giving you the on-demand delivery of the IT resources. So think about the Google Drive. Right. So we have Google Drive, which is providing you the storage. It's an example of public cloud. So whatever we are doing on the internet, it is about the public cloud. So, and private cloud is when an organization do not want to, let's say, for example, if you have on-premises data center, right? Now in your on-premises data center also, you do not want to share it with across the customers, and you want to have a private network only within your organization so that the employees of your organization can access it, or for example they can access it from wherever their office premises are, right? So it is only confined to specific people, specific networks. So that is an example of the public cloud, private cloud. Now hybrid cloud is nothing. Let's say your application has your organization has multiple application portfolios, right? Now application A is running on private cloud, application B is running on public cloud. So the combination is called the hybrid cloud. The hybrid cloud in itself is nothing but the combination of the public cloud and the private cloud. Okay. Now we will start with the AWS. So what is
Sorry.
Yes, Abdullah.
About the private cloud, right? So the private cloud is like you have a server and in your office and everything on that server, right? That server has no connection with the AWS or anything like that, right?
No, it has nothing to do with AWS. See, when we move into the course, we will see. So, for example, this is on-prem.
Right.
Okay, we call it as a private cloud.
Oh, okay, so on-prem, anything. Okay, I see. The cloud thing makes us confused. Okay.
Yes. No. I'll tell you the difference between the on-prem and the private cloud as well. Now this is AWS. Now some application is running here. Some application is running here. Okay.
Right.
Now this is an example of hybrid cloud because it may or may not be necessary that there will be a connection. Okay.
Okay.
So, for example, when you are, if we all are working in a corporate environment, you will have your machines dedicated to you, right? Which you cannot access outside your corporate network. right? But from those machines also you can probably access google.com, right? Or there will be some, for example, there will be some limitation what you can access or not. So these machines are also connected to internet, but you cannot access these machines. So there will be outbound connectivity, but not the inbound connectivity. You can not log into this machine from anywhere in the world. You need to be in this network to access these machines, right? Now this is an example of on-prem and the private cloud. Both criteria fit into this definition. Now the difference between the on-prem and the private cloud is, on-prem is both of the things will be on premises only, but with the help of private cloud you can still do the on-demand computing.
Right.
Okay, but with the on-premises, if you are completely on-premises, whatever server you have purchased, okay, whatever server you have purchased, they will be there in your physical data center, and some server admin or other maintenance guys, they will create a virtual machine and then they will assign the virtual machine to everyone in the organization. So that is like there is complete restrictions in the on-premises, but with the help of private cloud. Okay, so it's like it's an upgrade from the on-premises, but it's still not flexible as the public cloud. With the private cloud, there will be ample amount of servers will be there in your physical data center, and you can create the resources on demand, and you can release the resources when you are not needed. So IBM Cloud, Rackspace, these are example of the private cloud, but private cloud will be implemented on your data center only.
Okay.
Okay.
Got it. Thanks.
Now, if we talk about the AWS, AWS is a cloud provider, as we discussed. So, when we say it's a cloud provider, it's a public cloud provider. Okay, so they provide you with the servers and services that you can use on demand and scale very easily. Now, there is one more thing to clear the doubt. So, whenever we say public cloud, it means whatever servers you are going to connect, uh, you can access it via the internet. So you store any file, but that will not be the case 100%. If you can access anything from the public internet, then this cloud will not be secure. Okay, so there is a concept of private network in public computing. So there will be in AWS. For example, this is AWS. In AWS, now you can access AWS from internet. Okay, but inside the AWS there will be networks. We call it as a VPC. It's a virtual private cloud. Okay, now your instances will be here. So you can set up the complete network and access control mechanism from where you want to access those instances. Okay, so we will discuss about this at length in the networking section, but we can completely secure, even though AWS is accessible via the public internet, we can, in that case also, we can restrict the access and everything to these instances via this VPC mechanism. And the second thing is, let's say this is your data center, on-premises data center. Okay, then also we can connect this data center to this AWS via private connectivity. There are multiple methods of that, but these two can have a dedicated connectivity which will not go via the public internet. So this is also a very good example of the hybrid cloud.
Is that also an example of the edge?
Not exactly, Albert. I will come to the edge computing later on, but
Okay.
this is not an example of edge.
Okay. All right.
AWS provide you with with multiple services, okay, and there are more than 250 and 350, 300 plus services are available, and they are working on new services every now and then. So if you come after 6 months, there will be more services in comparison to. So the services will keep retiring, keep updating, and keep evolving. And as I say, AWS has revolutionized IT over time. Definitely because right now, if you see, especially after the pandemic corona, things are moving very fast to the cloud computing. Everyone want to be virtual, right? So AWS has the first mover advantage. Okay, AWS is the first major cloud provider basically. After that, Azure come, then GCP come, and there is other players as well. But AWS always has the first mover advantage, and it has the biggest community support, biggest professional support as well. And AWS powers some of the biggest websites in the world. So you can see the example Amazon.com and Netflix. Uh, Amazon.com is completely on AWS as well as the Netflix. Even though Netflix is a competitor of Prime Videos, even though Netflix is completely on AWS, they do not have any single server on premises. And apart from it, like if you see, I'm not sure if that is available in United States or not. There is another video streaming site like Disney Hotstar. So Disney is also completely on AWS. So
I
like
think
very
also NASA runs a lot of stuff on AWS.
yes, exactly. NASA runs. So even if you talk about any of the major Fortune 500 companies, some or other work, some of their workloads will be running on AWS. Now, there are certain companies which is completely going to Microsoft Azure. For example, AT&T is completely Microsoft Azure. Then Accenture is almost Microsoft Azure. But most of the big 500 plus Fortune 500 companies are running some or other workloads on AWS. So we are going to learn, as you see, this is just the for the reference purpose. We will learn more all of these services. So you are going to see Amazon EC2, ECR, ECS, Elastic Beanstalk, Lambda, auto scaling, IAM. So right now you will be understanding like it is looking too much, but we will go through all these services one by one. So first we will cover with IAM, then EC2 sequentially.
It looks overwhelming.
So it says navigating the AWS spaghetti ball. So see, what happens is, if let's say you know EC2, you are an expert in EC2, that does not solve any purpose basically. Because if you do not know how EC2 integrates with IAM, how EC2 integrates with KMS, how EC2 integrates with RDS, how EC2 integrates with SQS, SNS, then how EC2 is integrated with the CloudWatch. So the purpose of the slide is basically, it says EC2 integrates with this, EC2 integrate with this, EC2 integrate with this, 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 this. Similarly here, so each service integrate with one another, not with all the service, but most of the service. So for example, SQS. SQS integrate with Lambda, SQS integrate with Beanstalk, it's IAM, KMS, S3. So most of the service, if you want to create a large production grade application, right, you cannot build that over one service or two service, right? So you need networking services, you need compute services, you need storage services. So we need to learn those services in with integration to one another, and that is this slides is focusing. So these services are intermingled in such a way that even if you know one service completely, then might be your application is not going to work. Okay, so we need to understand the relationship between those services very carefully. So let's start with AWS. So it says in 2002, the AWS cloud was internally launched. Okay, and it powered its website Amazon.com. And in 2003, Amazon infrastructure is one of their core strengths. So they pitched the idea to market and they launched their very first service with the SQS. Now, SQS is a queue service, simple queue service, which is let's say if two applications is talking to one another, one application send the message to another application, so that message will be sent via the SQS. Okay, so this is one of the very first service that AWS launched. Okay, but then again, it did not, since it was a very individual service, it did not get much of the traction, and then they relaunched again in 2006 with this SQS was already launched with this S3 and EC2. Now these services has changed the game completely. Okay, and this is still today are the foundational service of AWS. Okay, so if you are going to learn AWS anywhere, the first thing is EC2 and S3. Okay, many people they know EC2, they are using EC2 and S3 on a daily day-to-day basis, but they still do not know anything about AWS. So S3 and EC2 are the fundamental services of AWS. So S3 is a storage service, while EC2 is the server service. So with the help of EC2, you can launch the servers on demand, while with the S3, you can have a virtual storage. So it is very similar service like Google Drive. In Google Drive, we upload the files, we download the files, right? Similarly, S3 is there. And it was launched in 2006 in the US East 1 region.
What does SQS stand for?
SQS is a simple queue service. It is sending the messages between application. Okay, so for example, there are multiple component of your application and they are talking to each other. Okay, so for example, if I take help of an e-commerce application, so e-commerce application, you purchase something, then you add those values to the cart. Now, based on the cart, your invoice will be generated. Okay, so the card service need to send the data to the payment service. Then only payment service will calculate like how much is your bill is going to be. So that communication happens with the help of SQS. It's a messaging service basically.
Okay.
Okay. So in 2006 they launched within the US East 1 region, and 2007 they launched in Europe. So we will see what does it means launching in US East 1 and Europe. And after 2007, all rest is history. And they are keep evolving, keep bringing up the services. Now, as we discussed, there are more than 300 plus services available, and all the major clients are there on the AWS. So you can see now Airbnb, NASA, Dropbox, and you see the startups also, whichever has started around 2010. Okay, they will mostly be completely relying on AWS for their infrastructure need. Now the reason for that is there is two terms. One is the capex, and another is the opex. Okay, so capex is capital expenditure, and opex is operational. So let's say if you are a startup and you have an idea which you want to develop and deploy it to your end user. So what is the thing you need? You need storage, you need servers, you need databases. So in a traditional computing model, what you need to do is you need to purchase everything. Okay. Now purchasing a software licenses, hardware, and the most important thing is you need a physical place where you are going to keep all of this. Either you will buy that place as well, or you are going to rent that place. So even before you start running the first iteration, you need to spend, or I would say you need to invest a considerable amount in the physical IT infrastructure, right? So that is called the capital expenditure. Even before running anything, you need a considerable amount that will go in purchasing all these necessary prerequisites so that your application run. Once the application is up and running, then probably you need some server maintenance guy who is looking out for the servers. Electricity you are paying on the monthly basis. So that is the operational cost, which is you are going to pay on a monthly basis. So capex is required to start running your application. That is like the prerequisite. But with the OPEX is the kind of the expenditure that you need to keep your application running once it is up. Okay. With the startup, they sometimes they do not have the required funds, so they do not want to invest their money in all these infrastructure, because they do not know if their idea is not going to work. They need to shut down, right? So all their investment will be like the base. So that is why they move to the cloud, because in cloud, if you're using cloud, there will be zero. Why? Because first, I do not need to have a place to contain my physical infrastructure like servers, databases, and all these things. Neither I need to rent it. Where they will be hosting, they will be hosted by AWS, and I am paying as a pay as you go. So whatever I use, I will pay for that. Simple. So it's the only operational expenditure. I will just go to AWS. If I need two server, I'll just say to AWS, I need two servers. They will create two servers for me. I need 20 servers. They will go create 20 servers for me. So it's like and for how much time you're using these 20 servers, you will be charged for that, nothing more. Okay. So that is why most of the small company, they go, when they're starting new development, okay, they go to cloud computing because the capital expenditure is little less or very zero. Okay. All thing is operational expenditure. So it's actually old slide. In 2019, AWS had 35 billion in annual revenue. I think in around 2023, this has more than $50 billion of revenue, and AWS account for 47% of the market in 2019, and that is somewhat still true. Maybe it will be somewhere around 43 to 44%, but still AWS is the market leader from a very big margin. Okay, and now it will be 14th consecutive year. So the purpose of this slide is there are multiple cloud providers are available in the market, but why you need to learn AWS is because AWS is still the market leader, and it has very far ahead in competition to its closest competitors as well. So if you see 22 or 47, it's like almost more than double, right? And it still has. So the more number of the people using AWS, the more number of the jobs will be available on the AWS. So that is why AWS still has the number one cloud, and it's like what we call it. Since the more people are, it's like the chain effect. You can say the more jobs are available, so more people are learning AWS, and since more skilled people are available with AWS, the companies want to adapt AWS because they find people which can work on AWS, which can solve their infrastructure architectural problem on AWS. And if I talk about in comparison to AWS, Microsoft is a good competitor of AWS, but GCP is still in very infant stage. Okay, there are multiple services which are available in AWS and Microsoft. It's not available in GCP still. So the only two competition is AWS and Microsoft Azure for now. Okay. Now, what you can do on your AWS? Basically, whatever you can do on your traditional computing model, you can do everything on the AWS. Okay. So AWS enables us to build sophisticated, scalable application, and it does not matter which industry you come from. It has solution for everything. You're coming from telecom, you're coming from retail, you're coming from financial. You can build any domain application on AWS. So enterprise IT, backup, storage, big data analytics, website hosting, mobile. Right now, if you see the AWS, there are services available for robo computing, edge computing, robotics, then AI ML. There's multiple use cases available. So basically, you can do with AWS what you even cannot do with your traditional computing. See what happens in the traditional computing. Let's say if you want to build a case for AI ML, okay, then what happens is you have a server, and on top of the server you need to install or configure the software that you are going to use for your AI ML use cases. Here we are going to get everything ready. We do not need to do anything. So for example, a very basic example is databases. Okay, so if you need to use a database in the on-premises environment, what you do, you purchase a server first, then you create a virtual machine on top of it, and then on top of your virtual machine you will install the database, you configure the database, you purchase the database license, and then your database will be up and available for your use case. There are so many steps involved in all of this. First you need to purchase a hardware, then you need to create a virtual machine, then you need to configure the database, install the database. So much activities are there. Here in AWS, I will just go to the console and I'll tell AWS I need a Oracle database, and the database will be up and running in less than 2 minutes. So it makes business IT operations very easy, and we can almost virtually can do anything and everything that we can do from the traditional computing. Okay, any question till now?
No, it's very clear.
Okay, so now AWS is it's a global service. Okay, so we need to understand the global infrastructure of AWS. So what happens is, let's say this is all AWS. Okay. Now, when we say I am deploying my virtual machine on AWS, the difference between the traditional computing and the cloud computing is you are not placing the virtual machine on your data center. Okay. We are placing the virtual machine on one of the AWS data center. In the end, it is all physical computing only. Okay. But it is virtualized to us. So when I'm saying I am creating a virtual machine on AWS, that virtual machine will be placed in one of the data center that will be managed by AWS. It's not it is running in air. No, it is running on one of the physical data center only, but I'm not managing it, so I'm not bothered about it. It is managed by whom? It is managed by AWS. Okay. And if anything goes wrong with the infrastructure, it is the responsibility of AWS. Now, AWS data center are span across the world. So let's say one data center here, one here, one here, multiple data centers. So I will show you this from the AWS website only. AWS global infrastructure. Okay, so if you see this slide, there's multiple green dots are available. Okay, so which means these are the points where AWS data center are available. So you can see in the most of the concentration is in the North America and in the Western Europe. Then we have some 2 data centers in India, 2 in Australia, and the red dot is these are the point where the data centers are in the process of uh, becoming available. Okay, so when you want to deploy something in AWS, you can deploy in any of the data centers. So what does it means is, if I'm deploying a virtual machine, I can deploy it in, let's say for the Canada Central, I can deploy in Northern California, I can deploy in for example, Ohio region, right? So there's multiple such locations are available where I can deploy my resources. Now these resources, we called it as a region. Okay, so region is, in one region there is 3 things. Okay, I'll tell you. First is region.
It's funny how they abandoned Russia and Africa.
Region, availability zone, and data center.
Thanks for asking my question.
Okay, so region is a physical geography where one or more data center is available. Okay, so if I'm saying I am deploying in my machine in US East 1 region, for example, okay, so then it means that my machine is going to be placed in one of the data center that is available in that physical geography. Clear about the region? So you can see there are more than 33 launched region is available, and some more will be coming soon.
So hold on 1 second. I have a quick question.
Yeah.
So the region, inside the region, we have multiple data center, you're saying, or like?
Yes. Yes. So for example, if I select this region, let's say, Canada West.
Sure.
Okay. So inside the Canada West, there will be multiple data centers. Now, the first thing is, we do not know the number of the data center in a particular region, and we do not know where are these situated. We just know that they will be situated somewhere in the Canada West physical geography. Okay. So, for example, if I show you from the console also, there will always be a region selected. So there you can select multiple regions. Okay, so in which region you want to deploy your resources, you need to select it from here. So for example, if I switch to US East 1 region, then now if I deploy my virtual machine, that virtual machine will go and get deployed in one of the data center that is physically situated in this North Virginia physical location. Now, we do not exactly know where that data center will be and how many data center is there. That is abstracted from us. That is a managed responsibility of AWS. But we just know we have a visibility till region, that I am deploying my machine in this particular region, so that it will go in one of the data center that is physically somewhere located in that particular location.
Beautiful.
Okay, so you can it's not only you are confined to one region. I can deploy 2 machine in one region, 2 in another region. So basically you can use all your regions, whatever is available. Okay, so it's not you need to deploy your resources in one particular region where you are. You can go global in minutes with AWS. You can deploy, for example, you can use this for the disaster recovery. You can do it, for example, for the high availability. And third is, let's say I am sitting in India, I have created a website. Now most of my users are coming from US region. Now if I deploy my website into this Hyderabad region or the Mumbai region, then the user which is coming from the US, they might face a certain latency because the traffic will flow from US to India, then the response will flow from India to US. Instead, what I can do is I will deploy my website sitting in India. I can deploy my website in Canada West or wherever my user base is, so that there will be no latency, right? So with AWS global infrastructure, you can globalize your application within minutes, just as a go, right? But if you have a physical data center, now that physical data center will be confined to only one physical location, right? So that's the major benefit of the AWS global data centers. Clear about the reasons?
I have a quick question.
Very good.
Yeah.
Yeah.
Yeah, so I'm not sure it's relevant with this topic. So let's say, as the example you just gave, like you have a custom users from USA and you wanna deploy your application and USA, right? What if you have some users from India and some users from USA, like 50-50, right? Are you gonna deploy two servers in two different?
Yeah, see, this is what you're saying is it's relevant, but it's very advanced thing. So there are multiple services are available, and it will completely depend on your architecture. So, for example, if you want to deploy it with high availability, so I will just give you the quick walkthrough of this. So let's say this is US region, and this is Indian region. Now there is a service called Route 53.
Correct.
Okay, I'm just giving an example. Route 53 we will cover later on. Now Route 53, in Route 53 you can define the routing mechanism. So what it will do is it is kind of, you can understand, as a load balancer. So what it will do is, if the request is coming from this user, okay, then it will see from where I will get the least latency. Okay, so of course, if someone is coming from US, it will go to US region. Someone is coming from India, it will go to India region. But let's say someone is coming from Europe region. Okay, now the request will go to the load balancer, and it will calculate the latency from both the data centers, and accordingly it will reroute the request to one of the data centers. So there is multiple things we can do.
So you're saying like all the routing rules we can set based on the geographic location, and we can point out which requests go to which server, something like that, right?
Yeah, this is one of the things we can do. But apart from it, there are multiple. There are 6-7 type of routing we can define. So, for example, this is latency-based routing. But there is something called geography-based routing. So, in which I can say, if the request is coming from US East region, then all the requests should go to the server, even though whatever the latency is. So, there is multiple customization also we will be doing.
Yeah. Got it. Thank you. I just need to. Okay, cool. Thanks.
So basically, the load balancer would be like an optimizer, right? To reduce the latency.
Not exactly. So I think we can keep the question when we will be discussing the Route 53, because first we will understand the basic. Okay. So load balancer is not the optimizer. It's basically, it is distribute the load to the backend server. Now in the backend, you can have multiple server, and how you are going to distribute the load, that you can define in the load balancer.
Okay.
Right. Now reason is clear.
Yes.
Okay. Now let's say this is a reason. It could be any region. Now, as we said, inside a region, there is multiple data centers. We do not know the number of the data center. That if I say in US East one region, there are 8 data center or there are 10 data center, that information is not publicly available. Not too publicly available. It is not known to many people basically. Okay, so we do not know. Now there is a concept of availability zone. Okay, so let's say there are multiple data centers are available. So let's say hypothetically, there is 9 data center are available in one region. Now that's only hypothetical. I'm not saying there is 9 data center. I do not know the number basically. Now every region is divided into multiple availability zone. So for example, this will be one availability zone, AG1, availability zone 2, and we have this availability zone 3. Now what happens is, inside the region we will have one or more availability zones. Okay, generally we have 3 availability zone in a region, and some of the region there are 6 availability zone. Now what is availability zone? Availability zone again is a collection of one or more data center. We again do not know the number of the data center. We are just assuming there will be one or more data center, because if there is only one data center, then there is no point of availability zone. So availability zone, we'll say, is a collection of one or more data center which are connected to each other by a low latency network and act as a single unit. Okay, so if let's say your workload is running on this data center, if something happens to this data center, your workload, if you are deployed in an availability zone, will automatically get transferred to this data center. So these 3 data center will act as a unit, even though physically they have a different physical location, but they will be connected by a low latency network, and they will be act as a single unit. So inside a region, you will have availability zone, and inside the availability zone, you will have the data centers. Okay, understanding availability zone is very critical, because some of the service as we will see, some of the services will be region specific, region scoped, not specific. Okay, so for example, you cannot copy one thing to another region. Okay, whereas some services are availability zone specific. So we need to understand the availability zone when we deploy your resources. So for the high availability, you can do the cross zone load balancing, cross zone disaster recovery. So as of now, understand this thing. The highest point is the region. You will deploy your resources in a region. Then inside the region, there will be there will be multiple availability zone. Generally, we have 3 availability zone, but some of the busiest regions will have the 6 availability zones as well. Okay, and inside the availability zone, you have one or more data center which act as a coherent unit, which are connected by the low latency network, and they act as a single unit. So if I'm deploying something to availability zone, then it means it will, in the end, it will go to one of the data center. But if something wrong happens with a particular data center, it will get switched to another data center, because you have deployed it to the availability zone. So it ensures the high availability in comparison when you are not deploying to availability zone, basically.
I have a question on the data center connectivity.
Okay.
So are they somehow physically connected, or?
Yes, they will be physically connected. Yes. So there in our, here we have defined, here also we have defined, see, not only the AWS data center, they will definitely be physically connected. Even if it is your data center, okay, you can also connect to AWS with the physical connectivity. There is something called direct connect. Okay.
So you are saying my on-prem the resources can be directly connected to the
Exactly.
AWS?
Yes. So it's a very long process, and it is there will be a dedicated physical line will be there from your data center to AWS data center. Okay, and you need to involve. You cannot just go and create this direct connect. There are third parties involved, which AWS is authorized to do this connectivity. So you request to them, and there is a SLA of more than 3 months to complete this.
Oh, okay.
Okay. So
And
these data
how
center.
about,
Mm-hmm.
yeah, go ahead. I have another question on
Yeah,
that.
go ahead.
So we are clear about the data center connectivity, right?
Mm-hmm.
How about AG? I mean, you said like there will be 3 AGs
Mm-hmm.
in single region or maybe 6, right?
Yeah.
How are they connected?
No, they are not connected.
Okay, so that's just like a group of data centers.
It's availability zone is like a group. See, in the end, everything is going to a data center, right? Data center is like your working host where these will be holding everything. So you group multiple data centers together and created a AG. So these AG are not connected to one another. AGs are separate. So if I'm deploying into here, okay, then my resources are here. You can do, these will be connected, okay, there will be another sort of connectivity, but they do not act as a single unit. So if something happens to this availability zone, for example, then your resources will not be replicated here, but you can do there will be like physical connectivity here as well when we do the cross-zone load balancing or other things, but it's internal to AWS. We are not known how these are connected. Even this data center connectivity is not known to us. Even we do not know the number of the data center, how many data center are there in a region. I was working in AWS also. In AWS also, very few people know where, even like if I say this is in North Virginia, for example. Okay, this is my region. Now in North Virginia, I'm saying 9 location where my data center is there. Where is these location? Very few people are aware about it. This information is not widely known. This will be contained within a very secured, and the team which is handling which will be their data center team is only aware about where their data center is and how they are connected.
I have one more. I have a question here.
Sure, yeah.
So inside the availability zone, we have the data center, right? Like for example, like AZ1, we have 3, right?
Yes.
If I deploy something, is it going to be automatically copied in 3 data centers for the?
Yeah, it's automatic. Even see, it is automatic. We do not do anything on that front. We will say I'm deploying my server on EC2. See, this is the conceptual knowledge. Why I am saying this is the conceptual knowledge? Because, for example, let me draw this. Let's say this is the availability zone. Okay. And these are 3 servers, 3 data centers in availability zone. Okay.
Right.
First, I do not know on which data center my workload is running. That is the very first. Right. You do not know. You know my workload are running here, but you do not know in which data center. Secondly, let's say my workload is running here and something happened and my workload get shifted here. Okay. You will not find that. It all happened internally.
I see. So I just deploy my service to the one of the availability zone.
Correct.
Inside how many data center I don't know. For example, like they will manage it.
Yeah.
Like they copy whatever.
Yes.
Will make it available.
Why they are telling this information that we do this replication, we do the failover? Because if this information is not available, you will say why we are using the availability zone. So the purpose of the availability zone is one or more data center working as a single unit. So if anything happens to one data center, all the workload running on that particular data center will be shifted to another data center, so that you do not feel a downtime. But first thing, you do not know how on which data center you are running. So if it's shifted to another data center, you will not get. So if anything happens to this data center, you will not even come to know.
Makes sense. Thank you.
Correct? Okay. So regions and availability zone and data centers are clear. Then we have the edge location and the point of presence. Okay. So edge locations are, so you can see 33 launch region and 105 availability zone. So mostly all the regions will have around 3 availability zones, so 99 availability zone, and then I think 2 regions have 6 availability zones. So then 105 availability zone is there. Now point of presence is it is like a regional cache. Now someone was asking about the edge location. So this is the edge location. So what happens is, now let's say this is your region, any region, multiple regions. Now you have a cluster where multiple customer of AWS is operating. Okay, so what you do is AWS will create a point of presence here, edge location or point of presence. So it's like a caching location, so that the frequently used data, they do not always go and access it from the region. They can directly access it from here. So that is we call it as location or the point of presence. It basically will be available where there will be multiple customer of AWS is confined, concentrated on one location, and the data that is very frequently accessed by the customer, that will be stored in the edge location, so that they do not need to go and query the data center that is available in the region because your application. Instead, they will store the data into the edge location, or we call it as a point of presence.
So the edge location is basically cache data.
Yes, cache data, you can say. Yes.
Cache data and cache storage.
Yes.
Okay.
Okay. So that is about the global infrastructure.
And does it mean like every country has each location, or like how does it work? Like here, the diagram you mentioned, right, on the lower one. I mean, for example, let's say US, right? Let's say North America.
Mm-hmm.
The North America, couple of countries.
Mm-hmm.
So let's Mexico has the edge location, or like how does it? I'm just
okay. So no, so every not the every country, because you see there is 33 launch region and there's a 600 plus point of presence. So in first, let's say in what would say, let's say in New York, the customer concentration in Manhattan. Okay, so in Manhattan they will create a point of presence, and apart from it they will create, let's say, wherever there is a point of presence, and then finally they will create a regional edge cache. So it is not available in any country, not specific to a country. Wherever there is the concentration of the customer is very much, they will create a point of presence over there.
Oh, okay. So here's an example. So we have a lot of Manhattan customer who regularly use some sort of data, right?
Correct.
So they're gonna create a edge location over there, and if the data is not found there, then probably if they're using US East, they're gonna hit the US East location, right?
Correct.
Depend
Yes,
on.
exactly.
Okay, makes sense. Okay.
Okay. So we have covered the regions. So AWS has region all around the world. Name can be, we will see EUS1, different names will be there. So this is a complete list of the regions. Region is a cluster of data center. And here, this is the most important thing. Most AWS service are region scope. So for example, if you are deploying any service, you are deploying it in a particular region because it will get deployed to a data center, and data center belong to a region. So if I'm deploying an EC2 instance, you deploy it to North America or Mumbai or Hyderabad. So it's scoped. Most of the AWS service are region scoped. Okay.
So can you go back to the
Yes.
I have a question. Sorry. Let's say Mumbai customer is trying to, they need Mumbai software development team need to develop some software that requires some service. That service is not available in Mumbai region, right? So they have to use another region where that service is available in order to build their software, something like that.
Okay, that is there in this slide. You can see the available service.
Okay, cool.
Okay. So let's discuss. So if you, as you said, if you need to launch a new application, where should you do it? Okay. So how would you select that I need to select which particular region? So first thing is the compliance. So there is with every geography, there will be certain compliance rule that you need to follow. For example, if you are working with a European customer, their compliance says that the data should not leave the European region, that their customer data, right? So if you are working with a Europe customer, you cannot deploy your application in North America or Australia or India region. You have to choose a region within the European Union, right? So first thing is you need to take care of the compliance. Second is proximity, of course, to reduce the latency. So if your customer base is wherever you have the most customer, it is advisable that you will deploy your application. You should deploy your application in that particular region only, so that they do not face latency issues. Third is available service. Okay, so it will be a very rare case, but let's say new services and new features are not available in every region. Okay, so if you want to use a feature that is not available in particular region, so then you need to select a region with compliance and proximity to keep in mind, and you need to select a region which has the service availability. And the last and the important point is, if you do not care about the following three factor, then the last factor is the pricing. Now, pricing varies region to region. Okay, so the price for one service can be different in US East region and AP South 1 region. Okay, so if you are not very much attentive to the compliance, proximity, then you can select a region which is offering you a cheaper service. So these are some of the factors that you need to consider when you are deploying your application into any particular region. Okay. Any questions?
Very good.
Sounds good. Thanks.
Now, as we say, availability zone also we have discussed. Each region will have usually is 3, minimum is 3, maximum is 6. Each availability zone is one or more discrete data center with redundant power and network and connectivity. They are separated from each other, so they are isolated from disasters, and they are connected with high bandwidth, ultra low latency networking as well. So that's availability zone. And now we have the point of presence as well. So content is delivered to end user with the lower latency because of the point of presence. Now you see this is an old slide. Now there is a 600 plus edge location and 13 plus regional caches is available. And you can see here in 90 plus cities. Okay, so across 40 plus countries. So wherever their customer concentration will be there, they are deploying a point of presence over there. Okay, now let's take a tour of the AWS console. Guys, do you have a AWS account?
Yes.
Everyone?
Do I have one?
AWS account?
No, I'm just getting used to the interface today.
But you have an AWS account, right?
No, I don't. I can access it though.
No, but how are you getting familiar with the interface?
Through the internet.
Oh, okay. So guys, we need to create the AWS account. So we are going to use the AWS free tier. account for our training.
Okay.
I'll show you how we can create an account. Create an AWS account. And get a free tier account. Okay, so it says create a free account.
Okay.
So you need to give the sign up. So here you need to give the email address or the AWS account name. So let's say let's try to give an email address.
I have an Amazon account already, so I'll use that.
Okay, yeah. And once you sign up, I do not have an email address which I can sign up because I almost use all my email address here. So basically, you just need to give your information and all these details. And in the end, you need to give your credit card details as well. They will charge you $2 for the verification purpose, and that will also be reimbursed. Okay, refunded. And don't worry, even if we are giving our credit card details, they will not charge you anything.
Yeah.
So it is completely secure. But they just
So
use
the
it for
$2 is for how long?
Sorry?
The $2 is for how long?
I'm coming to that. Okay. So $2 is
Okay.
a one-time transaction. This is not for how long. This is for just for the verification purpose that you are the
Okay.
right person.
All right.
You are a genuine person or not. It is not for it is not a fee. That $2 they will be charged. They will also, once the verification is done, that will also come back to your account. Okay. It's a completely free account.
All right.
Okay. So
Okay.
that you
Very
need to
good.
do. And then this is also my free account. Okay. I'm also using the free tier account. Now in the free tier,
Okay.
there will be certain limits. AWS free tier limits. You cannot use everything with the free tier. So there will be certain services that you cannot use with the free tier, and there is a limit for the services. So for example, if you see the compute, so Amazon EC2 is 12 for the 12 month is free, but in 12 month you can run it for 750 hours. So if you are creating a machine and if you are running that machine for 24 hours, then in a month you are consuming 720 hours, right? So the limit is 750 hours, but you can use up to 12 months. So there's for different services, there is a different limit. So for example, if you go to storage,
Okay.
so you can see there is a S3 that 5 GB of standard storage you can handle. And then we have EFS for the 5 GB, Amazon block storage 30 GB. So there is a limit that how much resources we can consume with this. I'll give you this link in the chat. You can refer this. And not to be worried, whatever we are going to cover in this course, all hands-on will be completed in the free tier. So just don't worry about the account. Okay, now if I give you the tour of the AWS console, so this is the very first page that we are going to land when we are going to log in. Here, it's your account details. So account ID is very important in case of AWS, and account ID is very useful when we are going to, for example, do the custom automations and all. So then you need to give your account ID, and account ID is the identifier for this particular account.
Right.
Okay, and then we have the regions. So whatever region you selected here, okay, your resources now. If I go to EC2 and deploy a EC2 instance, now my EC2 instance will get deployed into this North Virginia region. You can switch between the regions pretty easily from here. So you can see All of the regions are there. If I want to deploy my resources, for example, Mumbai region, I will just select the Mumbai and see my resources. I will get now into the Mumbai region. So most of the services we will see are the region scoped. So what does it means is whenever you select a service, the region will always be selected. Okay. So for example, if I go to EC2, Mumbai is selected. So almost 90 to 95% services are region scope, but there are few services which is global in nature. What are the services is that? So for example, if I do go Route 53, you can see here.
Yeah.
It's global.
It's global.
Route 53 and IAM. These two are the primary services which are global in nature.
Okay.
Okay, you can see this is global. Okay, global means why Route 53 is global? Because it has to distributed load to multiple regions, as we see in our example. Right. So if it is scoped to a region, then it cannot distribute the traffic. So Route 53 and IAM are the two services which are global in nature. Now, here there are certain settings like for any usual website. Then we have you can, if you want to raise a support, then you can raise a support ticket to AWS support from here. But since we are using our free account, it will be like you can raise a support if you have any problem with any of the services you are not able to work. All these details you can find it here. Okay. Then you have all the notifications. So if any issues happening with the AWS infrastructure, those issues will be listed here. Okay, any issues with your services, your infrastructure will also be listed out here. Then you can go to here also, you can go to services, not here, go to services and find out the services here. Like there are different services. If you click on all services, so then services will come up in an alphabetical order. Okay, A, B, C, and so. But if you know the category of service, let's say if you want to work with the storage service, so then there is a category of services. Now you see quantum technology, networking, migration, media service. There's a multiple machine learning, IoT, game development. So if you go to storage, there will be storage related services, backup, file server, and all these. Okay, and if you are, let's say, interacting with any service very frequently, you can make the service as a favorite by clicking on this star button. Now that service will come here inside the favorite. Now AWS backup is coming. So you do not need to search for service again and again.
This is really, really useful.
Yes, I think the graphical user interface of AWS is very good in comparison to Azure and GCP. This is pretty good, very neat and clean.
Wow.
And if you do not know how to search, look out for the service and you know the name of the service, you just search. For example, BPC. And here it will be giving you not only the services, okay, but it will give you the resources. It will give you the documentation as well, how you can use the BPC, BPC to BPC connectivity, all those things, knowledge articles, blogs, tutorials, everything it will give you. So for example, if you want to learn EC2, so you can see this is 34,000 documents available, 21 tutorial available. So you can search for everything. Okay. And then here health is coming, and here the cost and uses will be coming for you. So you can see the current month cost is $0. Last month cost was 0.67 and forecasted month cost is $1.55. So top cost of the current month, refunds excluded, you can see. So top cost is EC2 compute elastic file system. So you can get all these details. Now apart from this, we have some tutorials available. So there is, you can see, if you are very new to AWS, they will start with the very basic tutorial. You can go through these tutorials as well. So it is as simple as launching a virtual machine, start migrating to AWS, register a domain, right? All these are tutorials are available. Since we do not have any data, but let's say if you are running a very large infrastructure, then it will give you the details about how you can, what security vulnerability your data is having right now. Then blogs, announcement from AWS, and then there is a trusted advisor. So for example, trusted advisor, and we will cover the trusted advisor also. But basically, there is no recommendation because we do not have AWS business or AWS enterprise support plan. If you have a higher plan, currently we are running in the free tier, but if you have a higher plan, then AWS will keep analyzing your infrastructure and will give you the recommendation. Okay. So based on that, you can optimize your infrastructure. So for example, just a very basic example I'll give. You created a virtual machine and you are connecting to that virtual machine on port 22, doing the SSH, right? And then you open that port to internet. Now, this is not a very good security practice. You should not always open the port 22 to the internet. So now that will come as a recommendation from the trusted advisor that your port 22 on this machine is open for internet. You should not allow that. So you can act accordingly. So those type of recommendation you are going to find in the trusted advisor. So this is just a basic walkthrough of the console. Now, whenever you need to work for any service, and here you are going to see the recently visited service. Okay, you can do that, and there's multiple widgets you can create: favorites, manage instance, off summary, patch compliance. So you can see there's a multiple widgets you can create. Those things will be useful for which who are running very large infrastructure. Currently, we are just in the learning phase, so not very relevant to us. Now, whichever service we will be working, we will, let's say, click on EC2, and then it has its own interface that we will keep covering as we are covering the services. So this is just a basic walkthrough of the console. Okay, clear? Any question about anything? Any curiosity about the console?
Very good. This is very good. I have to familiarize myself with this.
Yes. It's pretty easy. Okay. Now we will start with our very first service, that is AWS IAM. Okay, so let's start on the IAM. Now, this is one of the very fundamental service, okay, and very basic service also. So the first one is called the IAM. IAM is called IAM stands for the Identity and Access Management. Okay, it's a global service because in IAM we are going to create our users and assign them to a group. So when you create a user, it is not specific to any region. Okay, you are going to create a user for all the regions. So IAM service is global in the nature. And when you create your AWS account, okay, so for example, when I created my AWS account, I used a particular email, and so the email that you use for creating your account is called the root account. So when you create your account in AWS with your email, that user is called the root user. Okay, so root user is like the owner of this particular AWS account. So here, if you see this Rochek, Rochek is the owner of this AWS account. This user can do anything to this AWS account. It can use any service. It can basically delete that account as well, because I'm the owner. If I do not want to continue on this account, I can delete this account, right? So the email that you are going to use while creating the account, it's called the root account. Okay, root account created by default, and we should not be use the root account for our daily day-to-day operations, or you do not need to share your root users credential with anyone. Root user should only be used for creating your AWS account. Okay, after that you need to create a IAM users. Okay, so users are people within your organization and can be grouped. Group only can contain the users, not the other users. Okay, users don't have to belong to a group, and user can belong to multiple groups. So understand, we will understand this point by point. So first thing is, are we clear about the root account? So currently we are using the root account, but in your best practice scenario, we should not use the root account. Instead, we need to create the IAM user for our account and start using that. Okay, now you can create multiple users, as you see from the diagram. Let's say I can create Alice, Bob, Charles, David, Edward, Fred. I can create multiple users in my account, and I can assign. So one thing is a user. Okay, second is a group. So you can create a user as well as a group. Now your user, they can belong to a particular group, they can belong to multiple groups, or they can exist without a group as well. So there's all the scenario are there. Okay, now let's do and create a users in IAM. So I'll go to IAM. The very first, will start from the very basic. Now if you go here in the access management, there is something called users. So I'll just go and just delete this user first. Okay, so now I do not have any user. Let's say I create a user. I'll create the user with one of your names. Let's say Albert.
How did I know you're going to use my name?
Okay, and I'll click on provide user access to AWS management console. And here you need to select I want to create an IAM user. Now there is two things. One is auto-generated password and another is the custom password. So you can give your custom password or you can use the auto-generated password as well. So let's say I use the auto-generated password, and user, there is a button. If let's say you are using a custom password, let's say I am giving some password, then I can, like, it's up to you. User must create a new password at the next sign in. Okay, so I'll just check on this as well and click on next.
Sorry, can you go back?
Okay, previous, yeah.
Scroll down. So here, two options: specify user in identity center. What is that? No,
we will cover that later on. So currently we are focusing on IAM. Okay.
Okay.
See, basically, user specify a user in identity center is, for example, if your organization is already doing already using an LDAP, Active Directory.
Okay.
Okay. So then you can integrate your Active Directory with the AWS IAM, so that whenever you are creating a user here, that user will also be created in LDAP.
Okay. Got it.
Okay. So I want to create an IAM user, and next. Now you can add user to a group. Group we will see later on, and permission also we will see later on. Next. Now you see a user has been created named Albert, and I will create a user. Okay. Now you see a console sign-in URL has been created for me. Either I can email the sign-in instruction. So if we click on So like you can send the email to the this user. Now what I'll do is open an incognito window and I can just go and log in. And the very first thing it will ask me to change the password. IAM username is Albert and the password is. Now once you sign in, it will ask you to change the password. Now you are logged into your AWS account. So you can see Albert at the account ID. IAM user is Albert, but if I show you my window, here it's not giving me the IAM user because I am the root user. Okay. But the problem right now is if you go, it will give you just a walkthrough of the console because here you see access denied. You cannot do anything. I have just created the user, but I have not tell the user how, like what type of permission I am giving it. So we will go back to the permission later on, but basically you can not do anything. If I go on favorites, so there will be no favorites. Let's say if I go to EC2, everything will be access denied. You see API error is Albert is not authorized to performance. So we will see the permission later on. So right now we have created a user and logged in with
no permissions.
Yeah. Now the first scenario we have seen that this user is without a group. Okay. So now the second thing we can do is we can go and create a group. Let's say developer. And here there is an option of add user to the group. I say, okay, add Albert to the group and I'll create the group. Now we have seen two scenarios. First, Albert was not part of any group. Second, Albert is now part of a developer group. I can create another group. Let's say architects. And you can see Albert is now part of. So based on this, users do not have to belong to a group. User can belong to a single group. User can belong to multiple group. But you cannot keep a group inside a group. Clear about the users and group? Any question? We have not given any permission to anyone as of now. We have just created the users and we have created the groups. Any question?
Nope.
Okay. Now, as we see, like just only creating the users will not make any solution, right? Because these users will not be able to do anything at all because there is no permissions attached to them. So the second topic in the IAM is you need to give them the permissions. Okay. So how we are going to define the permission is users or group can be assigned the JSON document called the policies. Okay, these policies are going to define the permissions of the user. In AWS, we apply the practice of least privileges principle. Do not give more permission than a user needs. So there is something called the permission policies. Okay, so you need to define these policies so that whatever mentioned in this policy will be assigned to the user. And one user can have multiple permission policies. So if you see the structure of the policy, first statement is the version. First statement is a version. Okay. Then you have the effect. effect could be allow or deny. Then you have an action. Action means what action you want to do on what resource. So we will see how we are going to create this policy, but I'm just explaining right now is the part of the structure I'm showing. In the resources, resources means let's say if you have multiple EC2 instance and you want to give permission only on a particular instance, so then that comes under the resources. Then you have action, resources, and effect, allow, deny. So that way you can define your policies. So right now if I go to the console, go to users, now here if you see the permission policies, here you see there is a policy called IAM user change password. And that is the reason it was allowed to change the password. Okay. If we remove this policy, then your user will not be even allowed to change the password as well. And if I open this, so there's a JSON document written which says effect is IAM change password, effect is allow, and the resource is your username. Simple. Now there is these, we can assign more permission to it. So there is two type of permission you can do. One is you can like directly assign this permission. So you go and click on add permission. So one is it's a best practice. We do not generally assign the permission to the users directly. We assign the permission to, let's say, groups, and we add user to a particular group. So whatever permission will be there on that group will be inherited by the user. Then let's say if I have a user and I can copy the permission of that user, so that exactly changing the copying the permission, that also you can do. But we currently have only one user, so that's why it's not displaying. Now the third option, and what we are more interested here as of now, is you can attach the policies directly. Okay, so let's say attach policies directly. Now you see there is 1174. So these are the policies that are already written. Okay. So for example, there is a policy called administrator access. Now in the administrator accesses, effect is allow, action is star, resources star. It means you can do anything with every resource. Okay. But there will be, let's say for example, read only. See what is the administrator access. So it's a administrator on the cloud formation. I'm searching for the read only. Okay, I'm not getting the read only for now. Search for. So let's say I am giving. Where is the admin? I'll give the administrator access for now, just for the demo purpose, and click on next. And I assign the permission, add the permission. Now, if I go and refresh this page, you can see all errors are gone, because now this users has the permission, right? So anything, there is two points. One is authentication, and second is authorization. So authentication, how we are doing is, we created a user in IAM, user with the help of username and the password, I can authenticate to use this AWS account, right? But once I'm logged into the AWS account, what thing I am authorized to do with the help of policies. Okay, now there is, like, currently we have given the admin access policy, but there is like multiple policies are available here. If you go again and add permission, attach policies directly, there is multiple policies. So let's say if I want to give only to EC2, right? So there is EC2 full access. So if I give this policy, the person will be able to do anything on EC2, but apart from EC2, he would not be able to do anything. Then if on EC2 also, if you want to give only the read-only access, so then you can assign this permission. So there's a different permission policies are available, which we can define. Okay, now there is something called AWS policy generator. These policies that you are seeing here, these are basically the AWS manage. Like, these are available to you. These are available to everyone basically. But let's say if you want to have one custom policy that you want to define for your infrastructure, so then you can. I will give just link to everyone. Okay, so here I'll select the IAM policy, and here I'll say allow or deny. So let's say I want to give access on S3, for example. So S3. Now you need to select the action. So there's multiple actions you can say. So I'll say list bucket policy I'm giving. Okay. And Amazon resource name I'm saying, let's say, on all buckets. Now there is one more thing that is called the condition. You can assign the conditions also. So you can see there's multiple conditions are there. Right? So you can select these conditions accordingly. So see, AWS current time, epoch time, source IP, user ID, multiple things we can do. Let's say I'm giving my name, add the condition, and it says generate a policy. Now a JSON document is generated for you. It says version, statement, action is S3 list bucket, effect is allow, resources is on every bucket, condition is if AWS user ID is equal to Rojak. Right. So that way you can generate the policy. Now in that policy only you can, let's say, on top of it, I want to give the permission related to EC2. Where is EC2? EC2. Now the action for EC2 might be different. Right. So associate route table, read only, get only. So this is so many is there.
Options.
So many options. So we do not need to, like, you and me, we cannot remember all these options. So we just need to understand how this works, and at the time of what exactly you want to do, you can do it. So now let's say I am giving the start instance. Resource name is start and add statement. Now generate the policy. Now this policy contains two permission. One, it is S3 list bucket, and second is it is allow you to start the instances. You cannot create the instances, you cannot delete the instances, but you can only start the instances, right? So that type of policies we can create. Clear?
Yes.
So you can assign these policies completely. There's more than 1100 policies are there. So based on the policy, you can do it. So let's say I remove the admin access for it. I go to Albert and remove the admin access. and I go, not the inline. From here also you can do the same thing. You can select a service. So let's say S3. Action allowed is allow or deny. Say I'll say all S3 actions, and all and next. So from here also you can create a policy. I'll give the name of the policy S3 all. So permission defined in this policy, you can see S3 full access and create the policy. Now here you see S3 all is a customer inline policy. It is not managed by AWS. Anytime you can delete this policy, anytime you can modify this policy, you can do basically anything regarding this policy. And now this policy is available in the policies here also. So here if you select the customer manage, so you say S3 custom policy is coming. Okay, and now if I again go to the users, what are the permission? S3 all. No, I think it is not coming. It's inline policy. We need to, if we want to persist this policy to other user, we need to create the policy from here. So it's similar, but we need to create it from here. It is inline as of now. It is only specific to that particular user. It is like permission on the fly. Okay. So now let me see if we have any bucket in S3. If not, I'll create a bucket. We have. Now if I go to my user and just refresh it, you will see again the permission denied error. Right? Because I have removed the admin privileges. But when I go to S3, you can see here I am able to see this. All the buckets that I have, I'm able to see it. Even if I go and create a bucket, then also I can create it. There is no permission denied error. Why? Because now such type of permission is given to me that I can only access the S3, not anything else. Okay, clear about the policies?
Yes.
So policies are basically is authorized.
It's authorization. Now,
yeah.
Let's say there's one last point. So for example, if you are from the developer group, so whatever policy assigned to the developer group, they will get to Alice, Bob, and Charles. Whatever assigned to operation, that will get to the Edward. Now, the question here is, let's say Charles, for example. Charles is part of developer and part of audit, right? Now, it will inherit the union of all these policies. So, for example, here I am saying S3 read only, and here I am saying S3 full access. So now, which is a bigger permission? S3 full access, right? So Charles will have the S3 full access. But in case of there is explicit deny. So for example, if for S3 there is a deny, we have seen there is two effect, either you can allow or deny, right? So by default, if it is denied, then this policy will be overwritten by this. So deny if you have, then it will override the any other group policy. So if you have a S3 deny, then this Charles user cannot even have the S3 read only permissions.
Sorry. So you're saying if one group has deny but other group has read only, deny will be overwritten by the read only, right?
Yes. If it is an explicit deny, then explicit deny is the highest privilege.
Okay, so deny has the high.
Yes,
okay.
Deny has the highest priority. Yes. If it is explicitly denied, then it has the highest priority. So policy structure we have seen. Okay. So yeah, I think we have come to a time. So the password policies we will cover in tomorrow's session. Anything? Any question?
No.
The slides will be good.
Thank you.
Okay, then I think we are good for today. We'll continue tomorrow.
Yeah. See you tomorrow. Thank you.
Beautiful.
Thank you.
Thank you all.
Thank you.
Thank you, Roshan.
Thank you, Edward. Thank you all.
Gosh,
So I'll
that was
upload the
really good.
recording in some time.
So you're gonna get an email to download that recording, right?
Yes, yes, yes. You will be getting an email to download it from
Thanks.
Daniel.
That's excellent. Thank you so much.
Thank you.
Yes, I'm actually drafting that email. You'll get it in 5 minutes.
All right.
So.
Good night.
Good night. Thank you.